In this section, we are going to be looking at using models to solve application problems. A model is a fancy way of saying an equation, and an application problem is one that's usually listed as a word problem, where we're often trying to find ways to either make the most money in a given scenario or minimize our costs. Looking at example 1, for the following exercises, A through I think it's D, we are going to use this scenario. Two different telephone carriers offer the following plans that a person is considering. Company A has a monthly fee of $20 and charges 5 cents per minute for calls. Company B has a monthly fee of $5 and charges 10 cents per minute for calls. For part A, we want to find the model of the total cost of company A's plan using the variable M for the number of minutes. So I'm going to use A for company A here. And M is going to be the number of minutes. And looking at company A, it says that we are going to be charged $20 as a flat fee, and then we will pay 5 cents times the number of minutes. So that's how we would figure out the total cost for company A. For part B, we're going to find the model of the total cost of company B's plan, using also M for the number of minutes. So for company B, the cost will be, let's see, $5 per month, and then plus 10 cents. Oops, not like that. 10 cents per minute. Okay. For part C, we want to find out how many minutes of calling would make the two plans equal. So what we want to do is take this and set them equal to each other. We want to know when company A total cost is equal to company B total cost. So we'll put 20 plus 0.05 M equals 5 plus 0.01. No, my brain doesn't want to write that number correctly. Okay. I'm going to make a little more space here. Let's move the 5 over to the left. Let's subtract 5 from both sides. So we'll have 15 plus 0.05 M equals 0.10 M. And then we'll subtract 0.05 M from both sides. I need to make more room there. All right, we've got 15 equals 0.05 M. And then let's divide both sides by 0.05. And it looks like we're getting that M is equal to, my calculator, 300. So it looks like both plans will be equal if we use exactly 300 minutes of calls. For part D, if the person makes a monthly average of 200 minutes of calls, which plan should the person choose? So we want to figure out how much will plan A be if we if we use 200 minutes. So let's just remember we have 20 plus 0.05 M. So we want to know what is A of 200 when we plug 200 in for M. Plugging that into the calculator, I am getting 20 plus 10, or $30. Let's do the same thing for Plan B. 5 plus 10 cents per minute. So if we plug 200 in, oops, 200 minutes, we're getting 5 plus 20, or $25. So it looks like Plan B is going to be a better option if we are only going to use 200 minutes. Moving on to example 2. A retired woman has $50,000 to invest, but needs to make $6,000 a year from the interest to meet certain living expenses. One bond investment pays 7% annual interest. The rest of it she wants to put in a CD that pays 15%. So this is an example that is very common, that people want to invest into two separate accounts, one that's a little bit more secure, more of a longer term investment, but the interest rate that's earned is lower. Putting it into a CD is more of a short-term investment, maybe a little bit more risky, and the person will have a little bit, sometimes more flexibility to draw on that money. So we want to know what combination we're going to take the $50,000 and put it into these two accounts. So for part A, it says if we let X be the amount the woman invests in the 7% bond, how much will she be able to invest in the CD? So let's just start by doing some definitions over here. We're saying that X is the amount invested in the 7% bond. And let's use the variable Y to be the amount invested in the 15% CD. Well, we know that X plus Y is going to be 50,000. That's the total we have to invest. So Y is going to be 50,000 minus X. Looking at part B, we want to set up and solve the equation for how much the woman should invest in each option to sustain a $6,000 annual return. So the amount of money that she's going to earn in interest from the first account is X, the amount she invests, times 0.07%. That's how much money that she is going to make on the first account. For the second account, it's going to be Y, the amount she invests, and the return there is 15%, so it'll be times 0.015. And we want that to total $6,000. Well, in this case, we've got one equation, but we've got two different variables. And we can't solve that unless we switch everything to be in terms of X. So this is where we're going to take what we found in part A and we're going to make a substitution here for Y so that we can have just X in our equation. So let's do that. Instead of writing Y, I'm going to write 50,000 minus X, and that'll be multiplied by the 0.15. So let's multiply the 0.15 times both of those items. And let's see. Oops, this should not be an equal sign. This should be a plus here. So I've got 0.07x plus 50,000 times 0.15 is 7,500 minus 0.15 times x. All right, let's combine the like terms here. The two items with x. This will be minus 0.08x. And then if we subtract 7,500, we are going to get a negative number here on the right, but we don't need to worry about it because you'll see we've got a negative number on the left as well, so those will cancel each other out. We're going to have negative 0.08x equals negative 1,500. And then if I divide both of these by negative 0.08, I will get that x is equal to, I'm getting 18,750. And then if we subtract that from the 50,000 total that we needed, hang on, let me make some more room here. We'll get that y is equal to 31,250. Let's just do a little work on the side just to check our answer. Let's just check our answer over here. We think that if we put 18,750 into the first account and we get 0.07% back, and then we put 31,250 into the second account, and that gets a 15% return. What do we get here? I'm plugging these into the calculator. I'm getting 318750, and then I'm getting 468750, and I'm going to add these together. Type something in wrong in my calculator. This number here is wrong. Let me fix that. Just hit a wrong number in my calculator. All right, let's double check now. Yeah, we're getting $6,000. Okay, good. Everything's good. So these are our answers here. How much we're going to invest in each account. All right. Examples 3 is slightly different than the 2 that we just did a minute ago. In this example, Ben starts walking along a path at 4 miles per hour. 1.5 hours after Ben leaves, his sister Amanda begins jogging along the same path at 6 miles per hour. How long will it be before Amanda catches up with Ben? So let's see. Let's start by drawing a picture here. I'm going to first say this. Ben's rate, how fast he's moving, walking in this case, is 4 miles per hour. And Amanda's rate is 6 miles per hour. I'm writing it in this way because what we're going to use is this equation that distance, the total distance that someone travels, is equal to the rate multiplied by time. So how fast they're moving multiplied by how long they were moving, right? Like how many miles per hour are you driving? How long did you drive? That gives you the total distance that you traveled. So let's put this as our starting place here. I'm just going to draw a little picture to kind of guide our thinking. And so 6 miles is the total distance that would be traveled after 1.5 hours. This is for Ben. How did I figure that out? Well, for Ben, the distance that he's traveled is his rate, His rate is 4 miles per hour, and he was walking for 1.5 hours. If we multiply that together, the total distance is 6 miles. So this is now when Amanda is going to start jogging behind him. So he's still going to keep moving, and at some point, let's say here, this is where they're going to meet each other, when she's going to catch up with him. So what we want to figure out is how far does he move during that time? Well, this distance is going to be his rate, 4 miles per hour, that's how fast he's moving, times some amount of time. We don't know what that amount of time is, but we're just going to say that this distance is going to be 4 times t. T is the unknown in this case. We don't know how long it's going to be till she catches up with him. Okay, so now that means that the total distance until they meet each other, the total distance until they meet each other is going to be 6 plus 4t. 6 miles is the first portion, and then 4 times t is the second portion. I know it's a little confusing because t to us is a variable for time, but we're taking 4 times the number of hours, and that will be a distance for us. All right, so now what we're going to do is we're going to look at Amanda. So let's look at Amanda now. If we think distance equals rate times time, the total distance that she's going to travel before she meets Ben is 6 plus 4t. Her rate is 6 miles per hour. And then the total time that she's traveling is t hours. See that the hours are going to cancel here. And so the equation we're trying to solve is 6 plus 4t equals 6t. If we subtract 4t from both sides, we're getting that 6 is equal to 2 times t. And it looks like we're going to get t is equal to 3 hours. So this makes it seem as though they are going to meet after Amanda has been running for 3 hours. Let's check our answer. Let's check. Ben first went 6 miles before Amanda's took off, and then he's going to go 4 miles per hour for 3 more hours. So this is his rate, and this is the time. Let's look back at our picture. He goes 6 miles for this first part, and then he goes 4 miles an hour for the next 3 hours. So it looks like the total distance that he's going to travel is 6 plus 12 is 18 miles. That's pretty far. Let's look at Amanda's distance. She is going to be running at a rate of 6 miles per hour for a total of 3 hours. That's also 18 miles. So again, the thing that we know is going to be the same for them is the distance traveled, and our answer is going to be that they will meet up after Amanda's been running for 3 hours.